Hello friends, hope you're doing well. Welcome to the 24th session of the SAT series. I know there is an upcoming SAT on the 24th of August and many of you would be gearing up for that. So wish you all the best for that. Let's get started here with our very first question. We will do a mixed variety of questions in this session, some from geometry, some from algebra and so on and so forth. Okay. So our first question, right? We have a circle with center O, okay, and ABC is an equilateral triangle, okay. The radius of this circle is 10 and we have to find the length of OD, okay. Now given the fact that it's an equilateral triangle, obviously we know that all the angles of an equilateral triangle are equal and they are equal to 60 degrees each. So each of these angles is 60 degrees, right? So this angle here is 60 degrees. Similarly this angle here and this angle here, correct? Because it's an equilateral triangle. Now we also know that if we have an arc, let's say BC, okay, and if it makes an angle of 60 degree with any point A on the circle, then it will make an angle of double of that with the center, right? So basically angle BOC will be equal to 120 degrees, right? So this is the arc BC, right? And if it is making a 60 degree angle here, then it will make the double of that with the center, right? The central angle is always double of the other angle. So this angle here is 120 degrees, right? So we're concentrating on this triangle OBC, and this angle BOC is 120 degrees, right? Now if we see triangle OBC is actually an isosceles triangle, right? Because obviously OC is equal to OB, which is equal to the radius, and which is equal to 10, right? So in an isosceles triangle, as we know, the opposite angles are equal, right? And this is 120 degrees. So each of these angles will be 30 degrees, right? So each of these angles is 30 degrees. Now, obviously, let's concentrate on this right angle triangle here, right? So we have O here and we have D. This is 90 degree, of course. That's given in the question, right? That OD is 90 degrees to BC. And this angle we just established is 30 degrees and the radius is 10. So it's as simple as that. If we have to find OD, we can use an appropriate trig function. In this case, we can use sine. So we can say sine of 30 degrees is equal to, let's say this is x over 10, right? Sine of 30 degrees is nothing but half. So we get x over 10 is equal to half. We cross multiply and we get x is equal to 5. So the length of OD is 5, right? Again, just to reiterate, it's an equilateral triangle. Each of these angles is 60 degrees. If this angle is 60 degrees, then this central angle is going to be 120 degrees. If the central angle is 120 degrees, then each of these angles will be 30 because it's an isosceles triangle. So then we focus on this triangle ODC. This is what we have to find. This angle is 30 degrees, the radius is 10. We use the sine function and get the value of x as 5. Next question. We have a function px which is equal to 24x cubed minus 36x squared plus 14, and we have to find the remainder when this function px is divided by x minus half, right? Now one traditional way could be that, okay, you do a long division and you divide this polynomial by this x minus half and see what is the remainder you get. Of course you can do that, but it will take quite some time and there are some chances of making mistakes there, right? So the expectation here on this question is not to do actually the long division, but to use a concept called as the remainder theorem, which says that, okay, the remainder of any polynomial, when you divide any polynomial by any other function, the remainder is going to be the value of the function when this divisor becomes 0. What I mean to say is that we have to make this divisor as equal to 0 and find the value of x. So we are saying x minus half is equal to 0, or in other words, x is equal to half, right? And then we plug in the value of x equal to half into this function, or in other words, we find the value of function at half. We find the value of p half, and whatever we get, that will be the remainder of this polynomial when it will be divided by x minus half. So let's see what we get here. 24 times x cubed, x is half. So 1 over 8 minus 36 times 1/4 plus 14, right? That's the value of p half, which comes out to be as 3 minus 9 plus 14, which is equal to 8. So 8 will be the remainder when we will divide this function px by x minus half. Okay, just to reiterate, what we are saying here is that whenever we are dividing a polynomial by any other binomial, the remainder would be nothing but equal to the value when we put this divisor as equal to 0, get the value of that x and find the value of that function at that x. Okay, let's get behind the scenes to understand why this is happening or what we are essentially trying to do. Okay, so when we say that we have a function, let's say we have a function fx is equal to, let's say, 2x cubed plus 8x squared plus 17, any function, right? And if we are saying that x minus 3 is a factor of this function, what does it mean? It means that there is some entity which exists in the world which can be multiplied with x minus 3 to get this, right? Only then x minus 3 will become a factor of this. So we are saying that we will have something like this. Right? So again, if x minus 3 were a factor of this function, then x minus 3 can be multiplied with some entity in the world to give you this. That's the meaning of factoring, correct? And if that is the case, the value of this left hand side will become 0 when x is equal to 3. Similarly, the right hand side will also become 0 when x equal to 3. Correct? In other words, how do we connect the dots? What we are saying is that if x minus 3 were a factor of this, right, then the value of this function will become 0 when we put x equal to 3. Or in other words, the remainder when we will divide fx by x minus 3 will be 0. In other words, what we are saying, that whatever will be the value of f of 3, that will be nothing but that will serve as the remainder. Now if x minus 3 is a factor, obviously the remainder is 0 and hence we are getting 0. But if it is not a full divisor, we will get some other value like the way we got in the previous question here, and that we got the value of 8. So 8 is the remainder when we divide px by x minus half. Question number 3. We have to simplify this expression. 1 minus I whole square divided by 1 plus I, right? So we can always expand the numerator either by the FOIL method or we can use a plus b whole square, right? We all know that a plus b whole square is equal to a square plus b square plus 2ab, right? So let's use that for the numerator here. So we get 1 square, which is 1, plus I square minus 2I divided by 1 plus I, right? I by definition is square root of -1, so I square is -1, right? We know this concepts here. So the numerator becomes 1 minus 1 minus 2I divided by 1 plus I, because I square is -1. 1 and -1 cancel out and we get minus 2I over 1 plus I, correct? Now at this point of time, we have to get rid of the I from the denominator. So we multiply this fraction by the conjugate, both the numerator and the denominator. So we do minus 2I divided by 1 plus I and then times 1 minus I and times 1 minus I, correct? The conjugate of 1 plus I is 1 minus I, and we are dividing this fraction by the conjugate of the denominator, both in the numerator side as well as in the denominator side, because we have to get rid of I in the denominator, right? Now if you see, the denominator becomes in the form of a plus b times a minus b, 1 plus I times 1 minus I, right? What is a plus b times a minus b? we know the difference of squares, and a plus b times a minus b is nothing but a square minus b square. Right? That's the difference of squares. Let's apply it here, and we get 1 minus I square, because 1 square is 1. On the top we FOIL, and we get minus 2i plus 2i square. I square itself is negative 1, so we get minus 2. Right? This is nothing but equal to 2, because I square is negative 1. 1 negative of negative 1 is 1 plus 1, which is 2. And on the top we get minus 2i minus 2. Right? We can split the numerator, and we get minus I minus 1. So that is our answer. Again, just to reiterate, we started on this question by expanding the numerator. Right? We used a plus b whole square is equal to a square plus b square plus 2ab. We used that to get here. I square is negative 1. Ones get cancelled out, minus 2i over 1 plus I. And after that, we multiplied by the conjugate of the denominator to get rid of the I. And this is what we get. Next question. If 2x minus 3 times x minus p is equal to 2x square minus qx plus 12, you have to find the value of p plus q. Right? So the first things which comes to our mind is that let's expand the left side. And obviously, if left side is equal to the right side, it means that each respective term should be equal to each other, right? The x square coefficient should be equal, the x coefficient should be equal, and the constant term should be equal. So let's expand the left side to see what we get. Now when we find the left side, we get 2x square minus 2xp minus 3x plus 3p. Right? If we see there are two x terms, so we got to combine them, or we got to collate them to find the actual coefficient of the x term. And we can do so by taking x common. So let's say we take x common, and we get minus 2p minus 3 and plus 3p. So this is our x square term, this is our x term, and this is our constant term. Correct? Now if this is equal to the right side, then as I mentioned, each of the respective terms have to be equal. Now 2x square is already equal to 2x square, but the x term should also be equal. Let's do that and find the values of each of them, p and q, and then we can add them to get the value of p plus q. Right? And the easiest one is the constant. 3p has to be equal to 12 because that's the only constant term on the left side, and that's the only constant term on the right side. So we say 3p is equal to 12, which gives us p is equal to 4. Correct? Let's now equalize the x terms. So minus 2p minus 3 has to be equal to minus q. So minus 2p minus 3 is equal to minus q. Right? This is the x term here on the left side, and this is the x term here on the right side. The value of p we already got as 4, so minus 2p is minus 8. So minus 8 minus 3 is equal to minus q, or minus 11 is equal to minus q, or 11 is equal to q. Right? So the value of q is 11, the value of p is 4, so p plus q is 11 plus 4, which is 15. So the value of this is 15. Okay? Just to quickly reiterate, we expanded the left side and we equalized the respective terms to get the value of p, to get the value of q, and just we added them to get the value of p plus q. Question number 5. So we have a quadratic equation here, kx square minus 2x square plus x plus 4 is equal to minus x minus 1. And we have to find that for what values of k will this quadratic equation have no real solutions. Right? Now we know that for a quadratic equation to have no real solutions, the discriminant has to be negative. Right? So essentially for doing that, the first step is to bring everything to the left side and to rewrite this quadratic equation in the standard form. Right? So that we can identify our a, b, and c appropriately. So let's do that. Let's bring everything to the left side. And let's also consolidate the terms whatever we can. Right? So we see there are two x square terms, kx square and minus 2x square. So like we did in the last question, I'll take x square common and I'll get k minus 2. So that becomes my a, right? The coefficient of x square. I bring minus x to this side, so it becomes plus x plus x is plus 2x. And similarly, minus 1 becomes plus 1, so 4 plus 1 is 5. So this is my standard equation. I've just rewritten this question into this form so that I can identify my A, B and C. Now this is my A, this is my B and this is my C, right? For a quadratic equation to have no real solutions, as we just discussed, b square minus 4ac, the discriminant, that has to be less than 0, right? Because when this guy is less than 0, the square root of a negative number will be imaginary or not real, and hence the entire solution will become imaginary, right? So let's apply this here. So 4 minus 4a is k minus 2 and my c is 5 is equal to, sorry, it has to be less than 0. So b square minus 4ac has to be less than 0. My b is 2 and hence b square is 4. So I get 4 minus 20 k minus 2 is less than 0 because I multiplied 4 with 5 to get 20 and then I will expand it in the next step. So I get 4 minus 20k plus 40 is less than 0, right? I bring minus 20k to the other side. I add 4 and 40 to get 44. So I get 44 is less than 20k. And then I divide by 20 to solve for k. And I get k is greater than 44 over 20, which is nothing but 11 over 5. So basically all values of k which are greater than 11 over 5, for those values this quadratic equation will not have any real solutions, because for those values of k the b square minus 4ac will become negative and hence the square root of the negative number is imaginary and hence the solutions will become imaginary, right? So k is greater than 11 over 5. Our last question here. So we have two parallel lines, L1 and L2, right? These two lines are parallel. L1 is parallel to L2. And there are some angles as they are given here. This angle here is 5x plus 4 degrees. This angle here is 5 minus 9 degrees. Then this angle is 3x degrees. And we have to find the value of x plus y. So several ways of doing it, right? Obviously we can find x first and then we can find y and then we can add both of them, right? The other way to look at something like this would be whenever they are asking for the value of an expression, whether it's related to geometry or algebra or anything else, typically there will be something given in the question wherein you don't need to find the individual values. You can always do so, right? But there will be something given in the question which will enable you to directly get the value of this expression. So keep that in the back of your mind. It may not work every time, but 99% of the times that's the expectation. Now when we look from that perspective, right, we do see that this angle plus this angle is equal to 180 degrees, right? Because it's a straight angle. Let's see what happens when we do that. So 5x plus 4 plus 5y minus 9 is equal to 180 degrees, right? 5x plus 5y minus 5 is equal to 180 degrees. 5x plus 5y is equal to 185 degrees. And if you really see, we can actually take 5 common here to get x plus y, right? And then divide by 5 to get x plus y is equal to 37 degrees, right? So as I mentioned, right, whenever they're asking for an expression, there will be something given in the question which will enable you to directly get the value of that expression. Now in this method, we have not even used the fact that these two lines are parallel and all. We have just considered this line and we have just done the straight line thing, that this angle plus this angle is equal to 180 degree, and that helps us to get the value of x plus y together, right? However, as I mentioned, we can find the value of x and y separately as well and then add them. Let's see, so these two lines are parallel. Let's extend this line a little bit, right? Now this angle 3x will be equal to this angle because they will serve as the corresponding angles, right? So if we see that this angle will also be 3x, this angle is already given as 5x plus 4. 3x plus 5x plus 4 is equal to 180 degrees. And we can find the value of x from there. Let's see. So 3x plus 5x plus 4 is equal to 180 degrees. It gives us 8x is equal to 176 degrees, or x is equal to 22 degrees. So we got the value of x by itself as 22 degrees. Let's see how we can use it now to get the value of y, right? As we just did, this plus this is equal to 180 degrees. When we do that, we'll get the value of y as 15 degrees, right? And 22 plus 15 will still get 37. So again, any which way is fine. You know, the point I'm trying to make is that whenever they are asking for an expression, give it a few seconds to yourself to see if there is anything given in the question which you can use to directly get the value of the expression, rather than directly finding the values of each one of them separately. Hello friends, hope you found the examples meaningful and useful. Keep practicing, and again wishing all the very best to the folks who are giving the SAT on this 24th of August. See you in the next session, and take care.